everyone. Our next topic is polarization of a dielectric. So in the previous video we have studied about the dielectrics. Dielectrics are basically insulators and showing a special type of the behavior when they are placed in the electric field. They are showing electric behavior in the electrostatic field. So you must know what is the polarization, that the process of developing induced dipole moment in the presence of external electric field in a dielectric substance is called the polarization of a dielectric. Mean to say that when the dipole, it may be polar or non-polar, there is separation of the charges, and due to separation of charges there is a induced dipole moment between negative and a positive charge. So to understand the process of polarization, we have to study the behavior of dielectric in uniform electric field. As we have studied the behavior of conductor in the uniform electric field, now we have behavior of a dielectric in the uniform electric field. So here we have two plates, A and B. A plate is positively charged having surface charge density plus sigma, and B plate having negative charge and having negative charge surface charge density. And you know that between the two plates there is electric field, and that electric field is uniform, and that uniform electric field is given by sigma upon epsilon naught. You know that the electric field between the two parallel plates is equal to sigma upon epsilon naught and E naught. This E naught is known as what? Applied electric field. Applied electric field. This is the applied electric field between the two plates A and B. Now between the two plates a dielectric substance is placed. Now dielectric substance that is placed. So you know that when dielectric substance that is placed, the dielectric substance are of two types, polar and non-polar, and whether it may be polar or non-polar, there is a elongation in the dipole molecules. Suppose these are the dipole molecule of the dipole molecule of the dielectric substance. So you know that here we have positive charge. Near the positive charge there is negative and there is positive charge. Negative, negative, negative. So there is positive, positive and positive. And here there is what? Negative charge on the B plate. So near this negative charge there is positive of the dipole. Positive, positive, positive and positive. So here it is negative, negative, negative and negative. You can introduce more. Here negative, positive, negative, positive, negative, positive, negative, positive. Now you see those are the intermediate charges. These are those lying in the rectangle. These are the intermediate charges. You see this positive and negative, this positive and negative, this positive, this negative, this positive, this negative, they cancel the effect of each other. This positive, this negative, this positive, this negative cancel the effect of each other. These are the intermediate charges, they cancel the effect of each other. Now we left with two opposite charges on the opposite face of the dielectric substance or dielectric slab. We can say that this is dielectric slab. So on this face of the dielectric slab there is only negative charge, negative, 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 negative. So here we can place negative charge, negative, negative and negative. And on the other opposite face of this slab there is positive charge, positive charge, positive charge, positive charge. And here we have plate A, here we have plate B. On this plate there is positive charge, on this plate there is a negative charge. So now we are left with only two opposite charges on the two faces of the dielectric slab, negative charges and positive charges. These negative charges are bonded with this positive charge on the A plate, and these positive charges are bonded by the negative charge on the B plate. These are bounded with each other, they are not free. So these negative charges and these are positive charges, these are known as induced charges, known as induced charges. And due to these induced charges, there is negative charge density on this face, and here positive charge density on the negative on the other face. So P, here we are placing a subscript P on the surface charge density, that is known as induced surface charge densities. This is negative induced surface charge density, this is positive induced surface charge density. Now due to these induced charges, there is an electric field inside the dielectric substance or dielectric slab. So you know the direction of the electric field is from positive to negative. So there is induced electric field. This is induced electric field. And in the definition we have written the process of developing induced dipole moment. Induced dipole moment. So you know that the direction of the dipole moment is from negative to positive. So there is what? Induced dipole moment. So this is induced dipole moment denoted by this small p. So this process of developing induced dipole moment in the presence of external electric field in the dielectric substance is known as polarization. And the process of inducing opposite charges on the two faces of the dielectric slab is also known as polarization. So this process is known as what? Polarization of a dielectric substance. So this is the induced electric field and this is applied electric field, and may I write here E naught, that is the applied electric field. Its direction is from A plate to B plate. So there is net electric field inside the dielectric substance, and that net electric field is written as E net which is equal to E naught. E naught is toward this side and EP in opposite direction. So here I am placing negative sign EP. So this is the net electric field inside the dielectric substance, which is non-zero. In the conductor we have said this net electric field inside the conductor is zero because E naught, the magnitude of the applied electric field, is equal to the magnitude of induced electric field. But here the magnitude of applied electric field is not equal to the magnitude of induced electric field. Here E naught is greater than EP. So about the process I have written. When we introduce dielectric slab between the conducting plate, then all the molecular dielectric substance experience a torque. You know that a torque. Initially when there is no electric field, they are forming a closed chain. All the dipole molecule forming a closed chain, and when they are placed in the external electric field, they will experience a torque and align in the direction of electric field. Second, interior charges cancel the effect of each other and equal and opposite charges are induced on the opposite faces of the dielectric. This process is known as polarization. So an induced electric field is induced due to the induced charges. Induced electric field is induced due to the induced charges. These are the induced charges. Due to induced charges there is induced electric field, that is given by EP is equal to sigma P upon epsilon naught. As here we have the magnitude applied electric field is sigma upon epsilon naught. Sigma is the surface charge density on the A and B plate, and sigma P is the surface charge density of induced surface charge density. So here we can write EP is equal to sigma P upon epsilon naught. So net electric field inside the plates or inside the dielectric is E net is equal to E naught applied plus minus EP, because this is in opposite direction. So here E naught minus EP. So E naught, that is equal to sigma upon epsilon, and this is sigma P upon epsilon naught. So this we can write 1 upon epsilon naught sigma minus sigma P, and this is the E net. If here there is what vector on the net electric field, so this is the magnitude. So here n cap, that is the unit vector that will give the direction of the net electric field, and net electric field direction is toward this side in the direction of the applied electric field, because E naught is greater than EP. So from this expression we come to know that so net electric field, this net electric field also known as reduced electric field, because there is sigma minus sigma P. So this net electric field also known as reduced electric field. So reduced electric field is equal to the applied electric field minus induced electric field. We can also define the reduced electric field is equal to the difference of the applied electric field and induced electric field. So this is all about the polarization of dielectric, and this polarization of dielectric is explained on the basis of the behavior of the dielectric in the uniform electric field. This topic is very important, and the purpose of this topic that will explain when we will study the capacitance. So thank you.